Imagine, imagine someone bought a rotten egg. Someone bought a rotten egg and it had some cracks in it. It had some cracks in it. And you get a foul smell and you get a bad smell. You get a bad smell. You get a bad smell inside your classroom. Inside your classroom. Now what you do? Obviously you're not going to go near to that bad smelling egg, and you're not going to enjoy the smell of the egg. You're going to go away from the egg, right? You're going to go away from the egg. So if you conduct this experiment, if you go near to the egg, the smell increases, and if you go away from the egg, the smell decreases. So there is something in the air. So there is something. So there was, or there is something in the air that is creating this smell, or that is responsible for the smell. Correct. So what is that thing? What is that thing that is in the air, that makes you experience a smell for a certain amount of time, or for a certain distance, and you don't experience after that. Suppose you close the door and get out of the classroom, you're not going to experience that smell, right? So what is that thing that is in the air? What name shall we give? I would like to give the name for that thing as field. I would like to call it in a more general way. I would like to call it as smell field. I would like to call it as smell field. Now this smell field decreases as you go away from it, and it increases as you come near to it. And this smell field, so how do we define the smell field? It is a region around which the smell of the rotten egg can be felt. Simple. Now tell me, what is a gravitational field? Now what definition can I give for what is, for the question, what is a gravitational field? Hmm? What is a gravitational field? Very simple. Suppose there is an object. Suppose there is an object. Let's say there is sun. Okay. So the force of attraction up to which the force of attraction up to which it can be felt is called the gravitational field, right? So the area, the distance up to which the force of attraction of the sun that can be felt is called the gravitational field. Very simple. So this is how the gravitational field is, and I hope you understand what a gravitational field is. Next, coming to the topic gravitational. Next, coming to the understanding of the topic, gravitational potential energy. Gravitational potential energy. Now, I would like to explain this with an example. Let's take a football. Let's take a for this. Let's take a football. Let's take a football. Okay, and let's take a tennis ball. Let's take a tennis ball and a football. And what I'm going to do is that I am going to attach some springs around the football. Attach some springs around the football, all around the football. Okay, what I'm going to do, I'm going to attach some springs. Now if I move this tennis ball towards the football from point A to point B, what happens? What happens if I suddenly release the tennis ball? So what I do is that, so there is this, what happens after compression. So this is what happens after compression. This is what happens after compression. What happens? So there is this tennis ball, and this tennis ball has been moved from point A to point B. This tennis ball has been moved from point A to point B. Now if I suddenly leave my hand, if I take my hand, what happens to the tennis ball? The tennis ball comes in the direction. The tennis ball will come with the force in the opposite direction. The tennis ball will come with the force in the opposite direction. Now my question is, where did the tennis ball gain its energy? Where did the energy come from? Where did the energy come from? Out of nowhere? So I have done a work, right? I have done a work in moving this tennis ball from point A, in moving this tennis ball from point A to point B, from point A to point B, and this work is converted as energy, right? Makes sense? The work that I have done is converted as this gravitational potential energy, right? Now, let's move into the understanding of another topic, gravitational, which is gravitational potential, which is gravitational, sorry, which is gravitational potential. So this gravitation potential is a very simple concept. Mm. This gravitation potential is nothing. It is the work done. It is the work that is done in bringing an object of mass, let's say m, from infinity, from infinity. Let's say this object, I take this object from infinity into a point, some point P. So if I have to bring an object of mass m from infinity and I have to place it in a point P, in a point P, so I have to do some work, right? That work that is required to keep at that particular point P, to keep at that particular point P is called as gravitation potential. So this gravitation potential gives me the information about this point. What work should I do? What work should I do so that I can safely place this mass m from infinity and to this point? That is the information that I get from the gravitation potential. Right? Understand? Is it clear? Now, getting into the previous topic, which is gravitational potential, let's bring some mass into this and let's make this system a little more related to life, right? So there is some mass, okay, there is some mass m, and I wanted to find the gravitational potential. Okay, I wanted to find the gravitational potential from a distance r from this mass at this point P. Okay, so there is this mass m, and I want to find the potential due to this mass at this point P. Okay, I want to find the potential of this mass at this point P. So this potential of this point, the potential of this point mass, let's say this is a point mass, and the potential of this point mass can be written as minus gm by r. The potential of the point mass can be written as minus gm by r. Now I wanted to bring another mass. Maybe I am bringing it from infinity, another mass m, and I am keeping at this point. Okay, I am bringing another mass m from infinity and I wanted to keep it at this point P, right? So what work should I do? Now another one question comes, what work should I do? What work should I do? What work should I do? This can be found, the potential is the work done on a mass. So the work done is potential times the mass, right? So from the equation 1 I can find the work done, which is minus g m by r. And as we have discussed earlier, using the tennis ball and the football example, the work done is stored as potential energy, correct? The work done is stored as potential energy. So I can write now the potential energy of this system is minus g m divided by r. So this is the potential energy that is in the system. Now I would like to add some more mass into this and see what happens. Okay, I would like to add some more mass into this. See, we don't like to be alone. We want more friends, right? Suppose I have myself Ajit, and I want some other guy Ramu, and we both find some other interesting guy Rajesh, and we three wanted to be friends, correct? So we start adding friends just like that. So I have mass m1 and I have another mass m2, and I have this potential of the system. Now what if I add another one mass m3 here over here, and let's say these masses are arranged in the form of an equilateral equilateral triangle. Let's say these masses are arranged in the form of an equilateral triangle. So the distance r, I would like to call this distance as r, and these distance are same in an equilateral triangle. The distance is same. So I ask a question: what is the essential quality for three friends to be together? What keeps three friends to be together, right? Is it snacks, or is it movies, or is it some interesting physics concept, or some song? What keeps three friends together, right? We get this normal question like that. What is the energy of the complete system that is keeping them together? That is, what is the total potential energy? What is the total potential energy of the system? In order to find that, let's we must add the potential energy, right? The total potential energy is u1 plus u2 plus u3 plus u3. So u1 can be found, which has already been found, m1 m2 m1 m2 divided by r, and u2 is minus g. U2 is nothing but the gravitational potential of M3. U2 is nothing but the gravitational potential of M3, the gravitational potential of M3 in the gravitational field of M1. And U3 is nothing but the gravitational potential of M3 in the gravitational field of M2. Understand? So U1 is the gravitational gravitational potential energy, is the gravitational potential energy in the gravitational field m1. And yeah, and if I want to find u3 is nothing but the gravitational potential energy that is required to keep the mass m3 in the gravitational field of m2, right? So in the journey of finding that, m1 m3 divided by r, and the next u3 will be minus g m2 m3 divided by r. Now adding all these to get the total energy of the system, so all the m, we know that m1 m2 m3, let's call all masses are same. Let's take a m1 equal to m2 equal to m3. Let's, for the sake of solving, let's take this masses to be same, and minus g m square by r plus minus g m square by r minus g m square by r. So what happens after this? I get 3 gm square by r. That's it. So this is the energy that I need to keep these three masses together. Or let's take this universe. We see those twinkling stars in the night sky. So let's take this. Let's compare these three masses to the twinkling stars that we see in the night sky. So if I apply the mass of stars, let's say the mass of the stars is same. Okay, so this would be the energy. This is the secret formula to find three stars to be intact. Got it. Next, I would like to raise more questions. Next, I want to let me raise some more questions from the system. Let me raise some more questions from the system. Mm, Let me raise some more questions from the system. That is, what will be the force experienced by one star? Okay, due to the other star. Let's take a let's take this equilateral triangle. Let's take this equilateral triangle, and three masses m1, m2, and m3. So I ask this question: what is the force experience? What is the force experienced by m3? So this m1 is pulling m3 towards it, and m2 is also pulling m3 towards it. So I have a vector here, and I know this angle of an equilateral triangle. The angle formed by the equilateral triangle is 60 degree, right? So I have two vectors aligned in here. I have two vectors aligned. So what is the resultant vector? How would I find the resultant vector? Now I can use this parallelogram of vector addition. So using that formula, the net force can be found, which is the force. Let's call this F1 and let's call this F2. So parallelogram of vector addition gives me that the net force will be equal to the sum of this root of squares of the forces f1 square plus f2 square plus 2 f1 f2 cos theta. This is the parallelogram law. Theta is 60, I know it. And then f1 and f2 I have to find. So we know that masses are same and the distance are also same. So masses and the distance are same, so the force is also going to be same. Let me call it f, just f, the force is just f. Now instead of f1 and f2 I can just simply put f. So what is that f? Force g m1 universal law of gravitation, g m1 m2 by divided by r square, g into what is m1 m, what is m2 m, r square is r only. So it is g m square by r square. This is what f. Now root of f square plus f square plus 2f square cos 60 degrees sine 30, which is 1 by 2. So root of 2f square plus f square. Now I will get 3f square, root cancels. So what I have is root 3f. Now what is f? Root 3 into g m square divided by r square. So the f net is, this is the force experienced by one star. Imagine you three friends, Ajit Kumar, Vijay Kumar, and Dhanush. Three actors are holding their hands, okay, or Surya, whomever you like. Three actors are holding their hands, and the force experienced by one actor, the form who are aligned in the form of a triangle, is this. This is the force experienced by them, right? Next, let's ask some other questions. Why don't we ask some more questions? What question shall we ask? What if I stand in the center of the triangle? Okay, what if I stand in the center of the triangle? Okay, let me put this question though. So there is this triangle and I have m1, m2, m3, and I am standing at the center, at the centroid. What is this called as? Centroid. This portion is called the centroid of the triangle. And if I stand in the centroid of the triangle and I wanted to, if I want to come in the centroid, what energy should I give? Okay, if I wanted to come in the centroid, so there are these three friends. Okay, there are these three friends, Vijay, Ajit, and Surya. There are these three friends, and I wanted to come and join these guys. Okay, and I want to come and be friends with them. I wanted to be placed in the centroid of the triangle. So what energy should I have to do that? What energy? What energy should I possess? What energy should I possess in order to do that? In order to find that, I need, so energy is nothing but the work done, correct? Energy is nothing but the work done. So we know that potential is nothing but the work done on the mass. So let's say that mass is m naught, the mass that wants to, the another one guy, let's say that is Dhanush wants to come, and the mass of Dhanush is m naught, right? So the work done will be potential times m naught. Simple, done. Now I have the mass, and what I need to find is this V, potential. So what is the potential? What is potential? What is the potential at centroid? What is the potential at centroid of equilateral triangle? Equilateral triangle. Let's find this. Okay. So the potentials is a scalar quantity. Potential is a scalar quantity, and we simply add it. So the total potential is nothing but of potential 1 V1 plus V2 plus V3. 3 masses, 3 potential. So what is the potential due to point mass? We know the formula, minus Gm by R. So this is V1, G11, V2, we know it, V3, we know what will come. Simple. But what is this r? This r is the distance from vertices, from the vertices to the centroid of the triangle. R is the distance from vertices to the centroid of the triangle. So what is this value? When if the side of the triangle is r, let's say the sides of the triangle is r, the value of this length is r by root 3, which has to be, this has to be kept in mind. This r by root 3. So keeping that in mind, getting to the problem, V total is minus G m1 divided by r root 3. So root 3 goes to the numerator, minus G m2 root 3 divided by r minus G m3 root 3 divided by r. Now, what shall I take common? I think the masses are same, so minus g m root 3. Everything is just common. So it is 3 times. It is 3 times. So I can write minus 3 root 3 g m divided by r. So this is the potential at the center of the triangle. Now let me go towards finding work. So the work will be minus 3 root 3 g m into m naught divided by r. So this is the amount of energy. So this is the amount of energy that I have to supply, for Dhanush m naught, for Dhanush m naught to join their friendship. So this is the amount of energy that I have to supply. Got it? This is the amount of energy that I have to supply for Dhanush to be here. Right. What questions we asked? So if initially we learned what is gravitational field, and then we get into learning what is gravitational potential energy, and then we went into gravitational potential, and then we just included some more mass into the system, and then we found what energy should the system have to be intact. What energy should the system have to be intact? So what was the energy that the system must have to be intact? Where is that? Yeah. So this is the energy that the system must have to be intact. So suppose if I want to separate the system, if I wanted to separate the friendship of Vijay, Ajit and Surya, what I should do? I should apply plus 3 mg m square by r. This is the amount of energy if I supply here. All these three guys, they go away. Dumil, they are no more. Okay. Now, next, what question did I ask? So, what is the force experienced by one of the guy? What is the force experienced by one of the guy? We found this, and then what could be the quality needed to get into their friendship? That is, what should be the energy that is needed to be inside this be inside this friendship? What is the energy that is needed to be inside this friendship? That is what we have found here. So you can compare it with the stars, or the stars in the sky. Initially the beginning of the universe, when the universe has begun, the universe has done the certain amount of work. The universe has done. If you compare it with universe, the universe has done this much amount of work in bringing three stars together. Suppose there are some three star system in the universe. Let's say the universe has done this much of amount of work in bringing the three stars together. This is the amount of work that the universe has done. Suppose the force experienced by one star will be this. Okay, and if another one star has to come inside, so this is the amount of energy that has to be supplied to the star. We can compare it in this way and understand these formulas are beautiful in a way. So yeah, raise some more questions. Okay, raise some more questions, and we'll keep digging deeper into this concept. Thank you.